Hello everyone, Jai Jagannath. I am Jasmine here. Welcome back to my channel Take and Beyond with Jasmine. In our last series, we discussed about subqueries and its types and use cases based on different business scenarios. Here I highly recommend whoever did not attend my last series, just go back and watch the series so that you can get thorough idea before getting into a new topic. So without delay, let's start our today's session where we are going to cover performance, security, automation, reusability of the queries based on the scenarios. So, this topic is about SQL objects. So, let's start. So, it's about SQL objects where we'll cover five types of objects. These are views, index, procedures, triggers, and functions. Where views will talk about abstraction and security. Second objects, index, that will talk about performance and speed. Third objects is about stored procedure, which will talk on automation. Fourth objects like triggers, which talks about auditing or automating change. Last objects is functions, which talks about reusable business logic. Here I want to say how it works. It will see simple. It will go to a library. It will not arrange, just let it be how it is. So we'll go and see all the books are on the floor randomly. So this is not a good manner to go and search the books. Okay. But if we'll go library where once you enter, the door is the automatic. We'll go and due to sensor that door will be opened. Then we will go to the librarian. Okay. Then we will ask for a book. So librarian, what he will do, he will search for the books in the system, sitting in front of the system. He can get on which side and which cell and how many books are there, which publisher, everything he can give you the idea or information about the particular book. So what do we differentiate about these two libraries? Here, if you will see more time, no results. But if you will go to the second one, you can save the time, performance is good, satisfactory. Okay, because everything was automatic, okay, and systematic and reusable. We can reuse whenever we can go and ask for any books for any subjects. You can exchange or change. Okay, so if we will go to the second and compare with these objects, then you can relate that views like abstraction. Suppose you are going for a books. Suppose you are asking for any data analyst books. So he will give a idea of 5 to 7 books are there in the system. So you can get a abstract idea or gist on that. Among these books, you are going to decide or finalize index, which will improve the performance. So that what you are deciding here, looking at the data analyst books, which books is the more relevant. So you can get and you can save your time. Okay. Then stored procedure, automation. If you want any other books related to data analyst, then that librarian respond to your questions like, yes, there are A, B, C, D books are there. If you will refer this, then you will get the benefits on this. Suppose for interview purpose, one books are there. For writing the exams or semester wise exam, then you can refer B books. If you want to prepare any competitive, then you can go for C books. Likewise, he can answer spontaneously. So what it is doing here, automation. He is checking through the system and he can, after that, he is responding accordingly. Trigger, suppose you want exchange of any particular books. Is there any other books? Then you will check in the system and you will respond in that. And function, how he is answering very spontaneously because he arranged systematically in his system. Whenever you are going and asking for the data analyst books I want, so suddenly he is putting through his system. Maybe he used any Excel logic or not also. He may use that Excel or not, but he has saved this file in a particular folder manually or automatically. But he is using the same logic in everywhere. Okay, so likewise, whenever we are writing the queries based on our database, what we got, sometimes our query may be lengthy or messy. So that our database becomes complex due to our long or lengthy queries. So to avoid this type of complexities or more time consumption or no reusability, we are going to perform or work on these objects. Using these objects, we can save the time, we can reuse that particular logic in everywhere, getting the input, how we can change or react to our output, or how we can speed our work process or system. Okay, so move to next slide. So what it says, whenever, here why I have put this diagram, because whenever you are going to do execution in your MySQL Workbench tool, that time you will find these components or these objects in our schema. Okay, whenever in MySQL, here I want to show you this schema. Okay, under this schema, I will hide these things. Now you can see only database names are reflecting. Okay, but if I want to show you an individual database, under this you can see tables, view, stored procedure, function. So far, among these objects, you can see view, stored procedure and function, that too under database. But if I will open this table, then under these tables, so many columns or fields or attributes you can see. Okay, but here why I open them? This is the tricky. Okay, all the columns you can see. Okay, suppose all the tables name you can see, but whenever I will open individual tables, then you can see under the tables what you will see first, all the columns name or field name or attribute name. Okay, so these are the columns. If I will open these columns, then these two columns it will show, but no need to show you. And yes, besides columns, what you can see, there are index, triggers, and then foreign keys. Okay, so index in our objects, here two objects you can find, index and triggers, that too under table. Each table you can find. You come to any table randomly, just pick it up. See, under each table you can find columns, index, foreign key, and triggers. Okay, so my question is, why you are getting that index and triggers under the table, whereas this other three objects like views, store procedure, functions, you will see under the database. Okay, so just it is the picturization diagram. Okay, so why index and trigger appear inside a table? As I mention every time, that inside a database you will get table, and each table consists of columns or attributes or field or entity, anything you can say. Okay, so and these columns, whenever we're going to improve the performance, we are applying that index or trigger, because what they will do, index belongs to one table only, and it is created on the table columns. Index means what? If you will open the book, it will show you first the cover page. Okay, then second page will be your talk. It will talk about all the index, like whatever chapters are there or contents are there, shortly you can go through the index. So it is created on table columns, and MySQL shows it inside that table only. Okay. Whereas a trigger also belongs to one table only. As I show you, each and every table you will get columns, index, triggers, and foreign keys. Okay, four things you will get. It fires before or after insert, update, delete on the table. These three commands are nothing but about your DML, data manipulation language. Okay, so it fires before or after, like it will react. Okay, based on the your data manipulation language commands. So it appears inside the table because why? Because anyways we are applying this insert, update, delete to a columns only. Okay, either insert the column, will add anything, or update any changes you want to do in your column, or delete any column. So for that reason only we are going to apply this trigger. Trigger, it will do change or react looking at the input. Okay, and index also will be applied on any table column, because what it will do, index will do, how I mentioned that it will take to the only index page, like only the gist of the contents in a nutshell. Likewise, it will show you only needed columns without going for all the columns. Okay, it will avoid the lengthy or complexities. Okay, what is needed only, that only it will show you, or it will create the index on that particular column, which one you want. Okay, so that's why we are using that index and trigger, applying each and every table. So you will see that index and trigger inside the table. Okay, and why foreign keys are here? Because foreign key, it will relate to your, when two or more tables are there. So concept of foreign keys will be existed in that table. Okay, so just go through it. Likewise, why view, store procedure, and function under the database? Very silly things. You need to know the answer. Okay. So you remember that in index and trigger we are using on a table. Okay. So next. So why view? Because view is whenever you are getting any multiple tables like 2, 3, 4, more than many tables you are getting, that time it will show you the view. Or on a short, you can see view is there to represent more tables. Okay. Stored procedure, they can run any SQL code not specific to one table. Okay. Functions, they are also logic. It's a reusable logic blocks and not tied to a single table, because any multi-tables will apply these functions. Because these view, store procedure, and function, they are only used for multi-tables. That's why we are using view, store procedure, and function. Views is kind of like similar to index, like how, because index is for one table only, while views are applicable for many or multi tables. Okay. Likewise, trigger is applicable for only one table when any changes or modification you are going to do. Likewise, for multiple tables, you are going to apply stored procedures. Okay. It will also do the automation in the many tables. Okay. And functions. Functions means any logic. Like, as you know, already we went through the topic about any aggregate functions, Windows functions, Scalar functions. Okay. So in this way, that means function is nothing but about your logic. That logic we are going to apply anywhere in for many or multiple tables. Okay. So that we can reuse it. So these view, stored procedure and function, though they are applicable for multi-tables, that's why we are keeping it under database. Okay, because database only carry multiple tables. Okay, so index and trigger you will get inside the table because they belong to particular or specific table. View, procedure, function inside the database because they belong to database, because they are carrying many tables. They are creating the relationships for many multiple tables. Okay, hope you got it. So now finally we are going to in-depth views. Okay, as I told, views where we'll get under database. Why? Because it will talk about the gist or abstract of multiple tables. So in short, we can say it is the simplify access and enforce governance. Okay, because views, it will talk about the abstract of the whole scenario, so that it will enforce the governance. Okay, so it will regulate the system. And then definition, what it say? A saved SQL query that acts like a virtual table. Virtual table created from the select query. Normally what happens whenever we write the queries for a table, we say that these were physical tables. But in those concepts, we'll get virtual table for created from a select query. Manually, what I write the query, this query is nothing but about your select statement or select query. So this select query becomes virtual table by we'll apply view or create view. Okay. So what we can say, views is a virtual table created from the select query. Okay. You don't store this data in any physical form. It is just shows the data from many tables. So why we are using? Already, as we know, what it will do, it will reduce our complexities. Okay, because if we'll talk about, already we know it is used for multiple tables. So how we are relating these multiple tables? Using joins. Okay, so this will first hide these joins, because many tables, if it will be there, then many joins will do. So it will take more space, more time, and also lengthy, and it will be seen like a messy or complexities. Okay, so it only require columns only. It will show you, so that it will show the security. Okay, and hide also complex joins and simplify the reporting. So whenever you will look wise, it will show you just a gist. So you can simplify it and avoid the rewriting queries again and again. Okay. So purpose in short, we can say it will show the abstraction, security, and stability. Okay, abstraction means it will hide the complex joins and calculation what we did it. And security purpose, we'll see it expose only the limited columns what we want. Stability, because it freezes the reporting contract of PI tools. Okay, so stability, you can say just from the point of view, okay, it will see when it does hide and limited columns, it is showing simplification, avoid rewriting. That means it shows the stability. Okay. So from the analyst point of view, what it benefits, okay, or what analyst gets the privilege from using the views. Analyst query clean, simple data set, prevents the access to the sensitive data. Dashboards won't break if table change. Okay. So if we'll go for the syntax will be like that. Okay. Create view, view name. Okay. Already we saw the virtual table created from a select query. So views, what it will do, it will give a table, but that table is the replica of the physical table. That physical table is nothing but about your select query, because select query only gives rise to your table. Okay. So if don't get confused, very simple manner, I will tell you that you just write the select statement, okay, and take the alias, but that alias will not give the after, just before to it, because we are going to the name it, and that naming through the view. So likewise, how we are making the table, that create table and then table name. Okay. Have you remembered that what are the columns? They are the data type. Okay. Okay. Likewise. So in the same manner, sorry, same manner, only the first statement, that create, just in place of table, just replace it with views. Okay. Create view, then your view name. In place of table name, just give the view name. Okay. So syntax, you'll have to remember, create view, view name, then alias as, then your select statement as usual. Select from where? As usual, the standard order, select from, select from, select from where, then multiple tables means, sorry, select from when multiple tables, then join, select from, join on, then where, then group by, then having, then group by, having, then order by, then limit. Okay. So you are talking about many multiple tables. So you will have to remember that select from, join on, then condition. Okay. So got it. Let's go through it. We'll do the case studies. So you remember what is view and where we'll get. View means it is a virtual table created from the select query statement. Okay. And syntax will be create view, view name, then alias arch, then all your select statement. Okay. Where you will get under the database. Okay. Next slide. So, case studies and view. So here we'll do a retail sector case study. Retail store Delhi sales dashboard we want. Okay. So problem is that A retail company wants a daily sales dashboard, and where the tables involved like this, that given table orders, where elements will be like columns will be like order ID, customer ID, product ID, quantity, unit price, order date. Okay. Then customer ID, customer name. Okay. And in products table, you will get product ID, product name. Okay. The reporting team needs customer name, product name, total bill. Okay. And order date. The query is long and repetitive, so solution is needed. Okay. So what we need to do, as we know that whenever many tables will be there, we'll go for the join to relate the tables. Okay. So here you can see, like for customer table, customer ID is the primary key. Okay, and here customer ID is the foreign key. If you'll see in the product table, that product ID is the primary key for the product table. But that product ID becomes foreign key for order table. Okay. That is the fundamental you will have to remember if you will make join. But here we are getting the questions based on view. So we will not go for it. Just I was making the clarification. Okay. So what it is asking, the team needs only customer name from here, customer name from the customer table, product name from the product table. Okay. And then order date where it is from the order table. Okay. Then total bill how we'll calculate based on the quantity and unit price. Okay. These two. Okay. So we got it. So why we need? Because our select query statement we need. Okay. Because no doubt only limited column business team wants. So where we'll get the business limited columns only we can show them, because here if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total 10 columns. Why will unnecessarily show them 10 columns? We can show only 1, 2, 3, 4 columns. Okay. So limited columns we want to show them. And also they want a daily dashboard report. So for every day they want to make it. So every day we cannot go for the writing select queries. So better to avoid this lengthy process, we need to go for view. Okay. So here nothing like complexity they have asked. Only they want 4 columns to show. So first, how we will show them? As usual, as we know, select our just write the standard order. Select from, join, then or. Okay. Then if condition. Okay. I don't think there is a condition, only for views. Okay. So view is nothing but your select statement. Okay. So here before to that, create view name. Okay. So view name you can say like VW underscore sales, any name just based on VW means view shortcut, save your sales dashboard they want. So view VW sales daily. Okay, any name you just give that to invalid way. So select columns which one you want to display. So as it mentioned, customer name, product name, and order date, that total bill. Okay, so just mention this. Okay, as we know, it is the concept of a join because more than one table. So we'll go for join. So better we need to give the alias for the table. Okay. So customer names like C dot customer name. Okay. Product name P dot product name. Okay. Then order date O dot order date, and then your total bill. So you just mention what sum of it will just mention price your unit price into what quantity. Before to that, just name that column through the alias like O dot unit price, O dot quantity. Okay, bracket close, and then make the alias again as total bill, because here it has been mentioned total bill. Okay, then from table name, why I mentioned here primary key, foreign key, and then primary key, which one is the only single primary key, that column is your primary key for the particular table. But when this primary key is available in other table, comma, that time it becomes the foreign key for that new table. Okay, so for order table it becomes foreign key. Okay, likewise product ID also. Okay, so in that, if we'll see, these two foreign keys are available there. So this is the most prime table. Okay, so first mention from order table. Okay, then join. Okay, from order, then join. I will tell you, then join any table you can join. Okay, customer, just mention the alias. Okay, then from order table, join customer table. Okay, condition on what order to customer, which one is the common customer ID. So C dot customer ID equals to your O dot customer ID. Okay, next again join this two table, join happen again, join with another product table. Okay, on condition that P dot product ID equals to O dot product ID. Okay, got it. Then before to that, so this will be your query. So here VW Delhi says what it says. It is a SQL view, a virtual table created from a query. It combines data from multiple tables into a clean, readable format. Okay, so view is simple, just simplification of many tables or multiple tables. Okay, see from order first, then join customer table, again join product table. Okay. If you are having any doubts, just drop a comment so that I can respond there. Okay. Then move to next. So we got view, but in how it helps analysts or any IT people in the day-to-day life. How view helps an analyst in making the report without going by the complex query again and again. So we can say it is the test time. Test the views. Is it successful or not? So we'll check it whether it is fitting or not. So select all from that table name. Virtual table name, we gave it VW Delhi sales. Okay. What were the customers' purchase and total bill on particular date? So likewise, how we did basically that purchase and total bills. What were the customer? Read many times to get the logic. Okay. So what were the customer purchase and total bill on November 24, 25? Okay. So date we got from here. Okay. So it says customer purchase and total bill. That means we'll mention all. Okay. So select all. Otherwise, it will get for total bill and purchase, customer purchase and total bill. Purchase, just go for it. Any purchase where you can see. So better total bill only will tell you that purchase. Also, you can get all the data so that you can relate. Okay. So For the particular date, we'll see all the components or all the columns what it says. So select all from that table name, virtual table name, where condition as usual. It comes under that 24th November 2025 comes under your order date. So where order date equals to your date with quotation will mention because it's a date format. Okay. Date. So you can just see view used combines the customer name, product name, and total bill. Date filter it does and purpose quickly retrieve the daily sales data for reporting or dashboard views for daily. Okay, so we got and to do practical. So view three tables were there. Okay, so first thing what we need to do whenever any question will be asked, your first duty will be no doubt go through the questions. Okay. Second, first go through the questions. Second, just write the proper query that will be applicable to the particular situation. Third, once query created, okay, then go for the testing. Okay, query writing, create query, create query. Okay, first thing. Then fourth is the your once testing is done, then execution output. Okay. So did you remember the query? We'll have to just logically go through the questions and write the queries accordingly. So view. Okay. So first I created the database, and once it is created, we'll have to activate by use that database name. Okay. So it will show like this. Okay. You will see like this tables, view, store procedure, and function. Okay. So create three tables as we saw that customer order table and one is the product table. Okay. So we'll have to first create it by inserting the data. Okay. So already I created these tables to save the time. Okay. So create table, table name, that column name. I will tell you just shortly. Okay. So you just go through it. Then create table, table name, open bracket started, close bracket, semicolon. Within this, all column names. So two column names, I think there were customer ID and one was the customer name. Okay. So customer ID, customer name. Then the data type. Okay. Customer ID will be the primary key. Okay. That constraint. Okay. So data type integer, then primary key. Okay. Done. Comma. Then customer name. That data type varchar. Okay. Then limit. Okay. Likewise, then once it is created, will execute, though it is already existed. Okay, you want to clear it also, you can clear. Okay, it's done. Then insert the data into the table. So how we'll write insert into table name, then values. Okay, values already bracket will give accordingly. Suppose customer ID, customer name, that means what, that customer name. Again, second row, like second ID for that name. Okay, so it's already existed. We don't need to execute again and again. So next product table, it is about product table. Likewise, we need to create and insert the data into it. Sorry, product table, product ID in primary key, product name, bhakar, limit, unit price. It will go for decimal. We'll keep it. Price means okay. Like after decimal, 2 digit will be there, and total 10. Okay, and then insert into that table name products and the values. Okay, so product ID, name, and price. Okay, likewise. Then next order table. Okay, it is your very long columns order, like order ID, that data type, constraint, primary key, customer ID int, product ID int, quantity int, unit price you need to keep decimal, order date, date function. Then why I will tell you is in that table foreign key were there. So that's why we are going to use foreign key. Okay, that foreign key, customer ID, okay, and references to which one actual belongs to which table, customer table it was belong to. Okay, first that order table to customer table, it will see, you can guess. Okay, so here you just check order table, customer ID, customer table, customer ID. So for that customer table it is the primary key, but when it will be considered in other table, it will become as foreign key. Okay, so that's why first we are taking the foreign key. Which foreign key? Customer ID, references to actually from where it belong to. So refer to customer table. Okay, that customer ID. Okay, so foreign key bracket customer ID, references customer table of customer ID. Here foreign key, here primary key. So in that table, what we got? Foreign key. So that's why inside each table you will get foreign key. Okay. See, foreign key index trigger. Okay. Close the bracket. Then insert data accordingly for the specific colors. Okay. Now we'll apply our views as it mentioned in the questions. Okay. Now we need to execute. Let's see. Done. Okay. Now what we'll do, we'll test. Once it is applied, we'll test it, then we'll get our output. Okay. To test the view, like how it helps. Test means we'll do all. Okay. So select all. All means start from table name. Here table name is the views table name. Okay. DW. Just check the spelling. Everything silly things matters. Okay. Select from table name. So let's see. Is it executed or not? It's executed. So it is shows only limited column which one we want. Like order date, then customer name, then product name, then total bill. Here like quantity into price. Okay. So it will show the output. Okay. So we got it. Then any output you want based on the specific. Okay. As it mentioned like order date, where order condition if you want to show. Here total purchase and bills. Okay. So what we'll do in same manner, Here just want to put the condition where how it is mentioned your order date equals to then order date here any order date you can see, but we will go for the questions 25 11 24. How to write year month date. Your month then date is there or not, let's see. Okay, so that data does not exist here. Okay, so likewise you need to run and execute. Okay, so done. So one more thing I want to show you. So what we did, where we can check. Okay, views. Okay, refresh this time. See, one created. That's why you got that alpha. Okay, BW Delhi cells. Okay, that only limited columns. Whenever you want to work any activities on these particular columns, you will go directly through that views. Okay, order date, customer name, product name, total bill, and also here you will see it will show the execution. Okay, it will take to another query tab. Okay, select all from SQL objects db dot directly see like under which database it is there and then views. Okay, because already though it is under database it is going like this. Okay, got it. And also if you want to that query part, how we did it, create that algorithm, what are the algorithm we put here. Okay, we created, then view, then select from, join, all this. Okay, and then here let's see what it talks about. So where we'll find it, we'll show all this, create time, everything, and comment it. Okay, it is a view. Okay, got it. So one view fit. Till now, store procedure function we have not worked. Once we worked on it, we will also see. Okay, now we will see our index. Okay, index. Where we'll get index? Under a table. Index will be used for one table. Okay, views used for many table or multiple tables. So index. Index is a data structure that speeds up the data retrieval. Okay, because index used on the columns, and columns when we are using columns only used for the data retrieval. Okay, a data structure that improves the speed of data retrieval operation on a table, allowing the database engine to quickly locate the rows without scanning the entire table. Previously what happened, whenever we used any changes or anything we want to retrieve, fetch the data, will have, though we are writing the queries through where, group by, having these things, it will scan the full data set. Okay, so to avoid this scanning, full scanning will go for the index, because index will show you the very limited column, exactly what we want, specific. So that's why that index also, different types of indexes are there. What are they? Single, mostly we are using clustered, non-clustered. Okay, so clustered means the physical order of rows. It is applicable only for one table. Okay, then single column index, what it says? As it sounds, single column. So speed of the query is filtering by one column only. Composite index, composite means multi. So useful when filtration or sorting by multiple columns. Unique index, that means no duplicacy. Unique. Okay, make sure no duplicacy values in the indexed column. Clusters means the physical order of rows only for one table it is applicable. Okay, and index, whenever any data sorting or data filtration, okay, that time we are using index because it's scanning. Okay, the concept and the syntax, how it is, those index applicable on the columns, that's the same manner. These objects we need to create every time. So create that index name, index, create index names on table name. Then inside that table name, table consists of columns. So just give the columns name, which columns you want to put or create the index. So on those specific columns, index will be created. Okay. So clustered index data is physically stored in the same order as the index. Index means sorting the data, okay, or filtering. So sorting the data. If we'll see the example, best example will be your library. Library saves, it has been properly arranged from A to Z books. Books are physically kept in the proper or stored order, sorted order. Okay. A table can have only one clustered index. Data is physically rearranged on the disk. Searching is very fast because data itself sorted, usually created through the primary key. If we'll see in the example, like here 1 RAM, 2 SAM, 3 is the SAM, anything. So based on ID only we can identify, okay, this name. If index is created on ID or primary key, data is stored in that order only. Non-cluster plus multi-column, it will tell about composite index. Okay, composite means multiple columns. When non-clustered is added, that becomes composite index. Non-clustered index, basically data is not physically stored in the order. The index creates a separate structure that points to the data. That points to the data. Just remember, a table can have multiple tables. Okay, data is not in the reorder or stored in physically also. Index stored pointers to the actual rows. So here that points to the data. Who points that index? Okay, so index will be acted as direction. Okay, useful for searching non-primary key columns like name, email, phone, like this. If we'll see the examples, suppose name pointer to row. So RAM here like row 1, SAM is the row 2, TAM is the row 3. Index on name column, it has been stored. If we'll see based on the parameters like features, clustered index, non-clustered index. So based on the feature, how we'll differentiate. Suppose data storage. You just tell me clustered index is the physical storage and non-clustered is the separate index plus that pointer. Okay, so the index will save or sorted the data. Count here that the count per table. Clustered index only applicable for one table. Non-clustered index for multiple tables. Speed here fast. Okay, because physically rearranged, and here separate index plus pointer, little bit slow compared to clustered index. Typical use here, primary key column will be acted as the filtration, And non-primary key columns here will act as the sorted point or typical use. Like for what purpose? Primary key column, here non-primary key column. Here many table, here only one table. Non-clustered, like separate your index plus pointer. So here physically rearranged. So speed is only one table. So first here a little bit slow. Index type columns clustered purpose. Suppose you will see single column index, that means for only single column it is going to be used. Clustered, non-clustered, speed search. Okay. And composite index, you will see multiple columns. Okay. So here non-clustered index we are going to use. Speed multi-column search. Clustered index, only one column or one table we are using. Clustered and sort the table physically. Okay. Then business case studies. Retail sector domain will see. Retail store sales dashboard. A retail company has a large table with millions of rows. Analysts frequently run the queries to filter orders by and to generate the daily sales report. To run the queries without index makes process too slow because the database does full scans through the entire table. So what we need to do now? Now it is saying create a composite index on columns, customer ID and order date. So why it told us composite index? Okay, because they want more than one column. Composite index when we'll use non-clustered index with multiple columns. So here columns will be like they needed customer ID and order date. Okay, so you just tell me where index will be applied. We'll apply the index on both the column customer ID and order date. Already it is mentioned that composite index you apply. Okay. So composite index is nothing but about your index will have to apply that specific column, not for all the columns. Okay. So how to write the query? Like create, we need to create. How to create? Create index, index name on table name, table of the columns. Okay. Got it? So create index. We give the name like IDX, customer, order date. In a valid way, just give the index or any object's name, whatever objects we are going through it, just give in valid way. Okay. So on table name like retail orders table. Okay. As it mentioned like retail table. Okay. So just give the table name and bracket inside give the column name like customer ID, comma, order date. So once we created, then what we need to do? We need to check. Okay. So after applying the index for filtration the data based on the selected columns, go for execution or test to retrieve the data by indexed column using the select query statement. To see the performance of the query, use explain to see that you will be able to know key details. Okay. So before to that, I need to show you why do we use explain. Okay. What is the difference? Okay. When you create an index, you must confirm is MySQL using your index. Explain shows the index name in the key column. How many rows are scanned? Explain shows row column fewer is better. Okay, what type of scan is happening? It will show. If you use explain, then it will explain in all and range. All means full table scan, which makes the process slow. Range index scan, that means fast. Did your composite index improve the speed? Without explain, you are only guess. Okay. But if I use explain, then it will give the details. Likewise, I have put the here the screenshot so that you can compare the difference. Okay. So what it says, it will select Developers. Now our duty is to execute the query. Okay, create index first. So first we need to create the table and insert the data. Okay, so let's see retail table index. Come here, create table retail orders and insert the data, then apply index, then execute the output by putting the normal query to retrieve the data. Okay, so create table of retail orders. What are they are? Create table, table name, then components like column, order ID, then data type, then constraint like primary key, then customer ID, data type, order date, date, data type, total amount like decimal. Okay, then already it is exited, so we'll go for, then these are the data we have put inside, like insert into table name, then inside table name all the column names. Okay, and then values. So now our duty is to apply or create the index on specific column, that to customer ID and order date. Okay, in that form we want to index these two specific. Okay, so what we need to do here, we'll apply how. Create index name on table name bracket this specific column name. Okay, so now run it. Okay, it's executed. Okay, now again what we need to do, retrieve data by filtering the condition on selected index column. Okay, suppose here is the, suppose question has been like this, like for the customer ID, before to that will show you. The next question, retrieve all the records. Yes, what I want to say. So just go through it. Why do we use explain? Okay, because I want to show you in that workbench tool. When you create an index, you must confirm is MySQL using your index. Explain. First one is the, is MySQL using your index? Okay. Yes. How many rows are started? First your task is the how many rows. Okay. Then second is the type. Third is the key. Okay. That composite index improve your speed or not. Okay. Three things: type, rows, and key. The next question says retrieve all the records of retail orders table by filtering between 1st Jan 25 and 30th June 25 for customer ID 1. Okay, so what will be our query? Select all from, because all the records they want to retrieve. Okay, so select all from table name retail orders where your customer ID 1 and then and your order date between 1st Jan, your month, your year month date format will become order date between and. Okay, in the same manner, it is like manual select query. Okay, that is the difference I want to show you. Only select without explain. I'm just putting it throws error. Okay, because SQL objects retail orders does not exist. Yes. Every time I will have that mistake, spelling mistake, silly things matters. Okay. Now see what it is showing. Null is the answer. So now if I put Jan 1st, 30th June, okay. Customer ID is 1. Now let's see, okay, because 1023 it is out of the data set, okay, so that's why it was giving that the null. Let's see, okay, so these are the retrieved data. Okay, so what it is showing, just simple manner how previously we did simple query, select query, how it shows, okay, but if I will do just copy and paste, it will be just before to that I will mention explain, okay, what it will do. That means this is the index with select. See what is the difference? Okay, that I wanted to show you. And these three things I want to just make sure it is there. So tell me what it is showing. ID. Okay, one. Yes. Select type simple. Table retail orders. Yes. Partitions not. Type range. So first, which one I wanted to know? Type range. Okay. Range means index is there and it has done the speed activities. Possible keys that IDX. Okay. That index name. Okay. Then key. Which column? Index column key. Okay. Customer order date. Okay. Then key length 9 and reference. Then rows 8. Filter 100 extra using index condition. Okay. You got it. So key your rows 8 and range key. Okay. And filtered also. Yes. Filtered. Okay. Okay. Without index and with index, what is the difference you will get? The database scans all the rows in orders, checking each matching customer ID and order date. This is so for the large data set because no index used. MySQL scan entire table, so it will take time. And what it will show you, type all, key null, rows 20,000 rows. But with index, what we did now, the database jumps directly to the relevant rows using the index, kept irrelevant data. This drastically reduces the query time. MySQL used in your index and fewer rows, query is optimized there. Because type is range, key is the index, column index name, and then rows 100. So here 20,000 to 100. Okay, so time save, query also optimized, and index used, and only few rows has been scanned. Okay. To see the performance of the query, because this is the very important question asked by interviewer. Many a times they ask. So this is the favorite question of interviewer. Because wherever you will get, our last target will be like performance should be better and optimized. Okay, efficient way how we can do. So this method is one. Okay, that index. Okay, we'll have to just explain it in this way and show them the clarity in that. Okay. Done. Here, what type? Type of scan. It says all means full and scan is slow. Range means index scan and fast. Okay. Type, where it is, type what type. Okay. And one more is the type row key. Okay. Key means index name and then key. Okay. Index name in the key column. And then rows. Rows, you saw the just difference that actual how many rows it was there and converted to how many. Okay, got it? This is the main difference. This part and this part. Type key rows. Index talks about these things for query optimization. Okay, then come to stored procedure. Uh, Index, one was there index and another one was there trigger. Okay, index for that only one table, that's a under table. Trigger also for one table and under this table. Okay, well, see, trigger means to change. Likewise, for many tables, when multiple tables will be there, that time you will act as that same to index, and your stored procedure will same to act as your trigger. So let's see stored procedure like automation, how they do. A stored procedure is a pre-compiled set of SQL statements stored in the database. Its purpose are like to encapsulate business logic, improve the performance, promote the reusability and consistency, supports the parameters for dynamic execution, ideal for automation and scheduled tasks. Okay, so these are the very, very important part because automation, every day we are going to automate manually, which are we are doing, these things will be replaced with the automation. Okay, so what its motto? Business logic will apply, improves the performance as it is pre-compiled and then promotes the reusability. Again and again we can use. Okay, and supports the parameters, whatever parameters or columns we want for the execution, and ideal for automation as well as the scheduled tasks. Okay, so let's see how is the syntax we are going to create for the stored procedure. Okay, so create procedure, procedure name, and then input in. Okay, here in means input. Input what we are giving? Parameter. That parameter with data type. Again parameter we will give, then data type. Okay, and arch alias. Okay, then this one will be inside that begin and end. And inside that begin and end, our SQL statements, SQL query or a select query will be there. Parameters are marked with in means for input. Okay, got it. Then business case study. Okay, so scenario based problem and solution. This is the for pharmacy case study. We'll see. Okay, suppose in any way we are using, suppose in pharmacy, how we are going to use it. My intention is whenever any sold in that medicine, okay, suppose one medicine is getting sold out, then my stock will be what? Reduced accordingly. So I want that changes. Okay, so how it will do automatically? So stored procedure. Okay, so pharmacy wants to reduce the stock automatically should happen whenever any sales happen. Each time they add a new sales record, stock should reduce automatically. The procedure needs these values to find the medicine, reduce the stock, insert the sales record. When he insert the sales record, he only wants to insert sales record. But output should be which one? That stock reduced automatically. Okay. Suppose if paracetamol stock is 100 and sale is 10, so how what will be the stock now? New stock will be 90. Okay, 100 minus 10, 90. So case 1, it is saying like sales table has rows When given cell ID 1, 2, 3, your maximum cell ID will go for 3. But new cell ID, how you will do? 3 plus 1, it will be come out 4. Okay. Likewise, when table is empty, when no cell ID in the table, okay, that means your maximum cell ID is null. No data we have put now. So what will there? You will use the condition, that if null condition. Suppose if null, inside that null and highest like 100, okay, that's stuck. So what will come out the output? 100, because null with 100 will be the number it will come out. So new cell ID will be like 100 then. Again then 100 plus 1 equals to, it will take as usual 101. Then so for the new cell ID column, you will use the condition formula that if null, okay, whenever any null value will be there, then how you are going to assume. So if null, that max of cell ID, okay, that which one we took null, okay, so for one time, so max of cell ID comma 100, then as usual 100 plus 1, so plus 1, okay. Hope we are getting. Then come to our stored procedure apply. How we are creating that stored procedure so that our stock will be reduced automatically when any sales happen. Okay, so whenever you will do in that simple manner, your MySQL throws you an error. For what reason that error 1903 it will happen. So just go through it. That's why I have put two. One is with error and one is the without error. Okay. So whenever I will do that general store procedure in that way, same format, only the difference due to that MySQL. Okay. Because MySQL will not support for the data manipulation. Okay. Statement. Already here the question is like when insert, when you will add any cell or insert any cell, that means your insert means your data manipulation commands. Okay, insert. So let's see how it's happening. Create procedure name. Okay, fine. Then bracket start our input parameter. Okay, input parameter first I took medicine ID, that data type. Okay, parameter, then data type integer. Then next input I put P underscore there, because P means pharmacy. Okay, that pharmacy quantity int medicine ID quantity date I need. Then input pharmacy date, that is data type date. Okay, then my input parameter completed. Then begin to end. Begin, then here end. Okay, then due to MySQL we will put that $2 symbol. Okay, then delimiter semicolon. Then inside that begin to end, we will use our normal select statement. So as I told, insert into the cells table. Whenever I will insert any cells, okay, item, it will how it will be. Insert into table name, okay. Then inside table your column name, cell ID, you want what you want to keep, cell ID, medicine ID, quantity, cell date, then values. And inside that values, what will happen? Because this is the new value, how will take it automatically. So as that's why I showed you that whenever any null element or new element, how will add up. Okay. So select if null, max of cell ID, comma 100 inside then close bracket plus 1 from cells table. Okay. Comma 1 is the that cell ID. Okay. How the cell ID will be shown, and then medicine ID, then quantity, then date. So 1, 2, 3, 4 things: cell ID, medicine ID, quantity, and date. Here as it is. Suppose cell ID, for the sales ID value will be like if null. If null, suppose whenever any null will be not there, then simple sales ID plus 1 plus 1 it will take. But whenever any null value will be there, how it will take? That if null, that's why we will put what? If not, max of cell ID, comma 100, then close the bracket, inside that bracket these things, and then plus 1 from the cells. Then comma, as usual, your medicine ID, quantity, and the date. Okay, and then updation bar. How we'll do the update? Same way, like set table name. Okay, set update table name, then set what you want to change. Set means it will do the change, which change what you want to do, like stock equals to stock minus p quantity. Okay, where medicine id equals to p dot medicine id, because both id should be same, medicine id, because what we have given the input, that input with your insert medicines id should be same, and then delimiter. Okay, so why I told you it will throw the error in that way, because see here already process cell. Okay, and here insert into cells. Okay, so same time, second time again it cannot take the same table for that to execute. Okay, so that's why what we'll do to avoid this error, we need to mention a new or declare it through the new table name. Okay, here see cells and cells. So we cannot, so already process cell as it is, let it be. Then begin. Okay, so just see the difference where we are making the difference. So here after begin, we just need to declare that table. Declare new cell ID, then data type int. So we took the column name. Okay, then get what we'll do, step 1 we'll do here, get new cell ID, separate select allowed we do. So for that we will do in a separate way. That cell ID how we put directly here. Okay, that if null this condition values, so we'll not do in that way, we just declare separately. First declare new cell id int. Okay, then select if null max of cell id comma 100 plus 1 into c, select this column. Okay, then into new cell id from cells table. Okay, got it. In select query way we need to write. Then step 2, what we did, insert cell using variable. So insert into cells, cells ID, medicine ID, quantity, cell date, then values, then new cells ID. So that cells, and here again like cells. Yes, see, not this one. Here see, I see. This is cells, and again here see one cell we used here. That's why, because of these things, MySQL will not support these things two times, because though it is a DML commands, so MySQL will give the error 1903. So error 1903 is only be visible for this DML commands. Okay, so we cannot use same table for twice. Okay, so that's why we took separate way for that new cells ID. Okay, so after that how it was, likewise new cell ID just in values we'll put. Then update how it was, like update table name set, update set, then where condition, update table name set which one you want to, that stock equals to stock minus quantity, where that medicine ID both, like your procedures parameter, and here execution like insert one, it should be same medicine ID, and then end, then delimiter, end the double dollar symbol. Okay, so begin to end this matter. Then we go for the testing or call the process, but that call the process it will come automatically as I showed you. Okay, so now let's see. Okay, so stored procedure, already I created the table medicines. Okay, here two tables. Okay, create table medicines and cells. Okay, create table medicines, medicine ID, that data type, then constraint. Okay, then medicine name, name will be bhakka data type, then limit, then stop, it will be int. Okay, then close, then insert the data into it. Okay, then sales table, create table cells, your sales ID, medicine ID, quantity, sales date. Okay, then data type and which one will be the primary. Okay, then in same manner I inserted the data, then stored, create the stored procedure. Okay, so I got, okay, starting from delimiter, sorry, okay, delimiter to, it will be ended in delimiter. Okay, we'll do, see what I want to show you now. So just in schema side, I want to make refresh. See here, after use the store procedure, it shows aroma. So our create store procedure, that process cell, it got executed. Okay, so here new sales ID I declared. What I need to insert sale ID, that medicine ID, quantity, sales date. Okay. Once I put, my stock will get automatically reduced. Okay. Stock minus quantity will execute again and again. Okay. So this test procedure, by calling, it will take you automatically into a new tab. Okay. How it will take us new tab? So just see in this, whenever you will come to that process cell side, it will show two symbols, one screw symbols and one is the some zigzag type. Okay, so just click on that second table. Okay, see, it will give the medicine ID, quantity and date. Okay, medicine ID, quantity and date. Medicine ID, quantity and date. Okay, because in our output table we want to see what, that stock. Okay, once the sale happened, that stock got reduced with sales ID. Okay, so that's why just here that error 1093 occurs only when you update, insert, delete a table while selecting from the same table in the same query. Okay, so what we did there, though we took that table name as usual for our insert, but in that we did that for the new sales ID column we used, sorry, again that same table, sales table we used. That is the reason MySQL did not allow to do. Okay, so insert, update, delete. Okay, for that, because MySQL is confused whether it should write the original table or updated version. Okay, so how to fix it? Whenever this 1903 error you will get, either for the store procedure you use variable. Okay, how we did it, that declare new sales ID column name, that data type. Okay, for manual query we use derived table alias through alias name. For production database we'll use auto increment. Okay, so in three way we can verify. Okay, Suppose here, here we get, in that second option we'll get that medicine ID, quantity, date. Okay. Suppose select and how to call the procedure after writing the query. Select and click on the generated procedure name process cell as the table name in shown image. Then click on the second button as I told you. Okay, once clicked it will throw a dialog box. Okay, that to call the stored procedure for the value enroll for inserted column as it shows. Only value entered. Click on execute, then it will automatically create the statement of inserted value in a new query tab under name process cell as you see in the image. Okay, suppose I will take, it is easiest way na, automatic automation part. Okay, so call stored procedure. Okay, no need to write the query again and again for this. Okay, suppose medicine ID, we will take one, will take. Okay, and quantity will put 10 this time, and the date will be next. Let's see which one will put medicine ID, quantity, and date. Okay, medicine ID, here what we have taken, medicine ID 1, 2, 3. So same we'll put for 1. Okay, 1, 1, quantity already 10 has gone. So same will take 2025 Jan 1st. Okay, now 3rd Jan, 5th Jan, again we'll put for 7th Jan 1. Okay, which one we'll put 1, quantity suppose 15, and the date, year, month, we'll put 7. Okay, 1, 15, 7, date, it will show. Okay, now we'll see our output. Okay, same way, what we want to see. Okay, write the query as it is beautiful. So what we want to display, we want to medicine ID, okay, medicine name, and then stock. Okay, so what we'll write, as usual, select, just take the proper way how we use. Here also you can write, here also you can write. Let's see what is it. Select, we want, and ID, medicine name, ID, stock, I think. Okay. ID. Just cross check how you are writing for that input. Okay. Medicine ID, stock, medicine name. This medicine. Stock from table name, medicine, where medicine ID equals to 1. Okay. That table name also cross check its medicines. Okay. Okay. So here also it is not showing. Okay. So, but why it is not showing? Here it is coming. Okay. So just will check the date inside the cell. Save date. Okay. Medicine ID suppose will take 2 distance. Okay. Quantity suppose within 5 will keep date. Maybe 2025. Okay. 2023 January month 25. It is it is taking a lot. Still it is not showing. Everything has got executed, but still it is okay. It will take the same value. It will take like 1, 10, 22 to 1. Why it is like this? It should not come like this. 1, 10. The new medicine ID will calculate 1, 2, 3 plus 10, 4, quantity 2, date 20, 25, 0, Still it is not showing. Where is the fault? It should show. Suppose in that paracetamol cough syrup will do. Suppose cough syrup ID is 3, okay, and name cough syrup, okay, stock is 43, 40 stock is there, okay. Mm, Here we'll go to sales table. Second is somebody 3. 3 is not there, okay. We'll do one thing. 3 will take here, then quantity 1 will do, and here date suppose 6 will put, okay. Medicine ID will put 3, 2 will put date 20, 25, 0, 2, 0, 1, 6, every time it goes only to select made ID, the medicine name it will show, and the stock with ID 3. Still it is not showing. Where is the anyways, just see like the error. So we are getting the error, but output will come like this: medicine ID, medicine name, stock. Okay. So here answer will be like medicine ID like 3. Okay. Medicine name it has cough syrup. Stock will be like 40 minus 2 like 38. Here it should come. Everything is coming, but our result is not showing us. Why? And will get executed in this side. It should come there only I got. Anyways, our table is not showing, but here I wanted to show you that it is without index type. It is showing. Okay. All from why it is not coming? So here we will see that all queries here it is restored. Okay. Whenever you want to make it use, you can reuse. And here like you need to put the entry. Okay, new here enter the values of parameter of your procedure and click execute to create an SQL editor and run the call. to create an SQL editor and run the call. Okay. Anyways, we will just put and execute. Okay. And run on the SQL editor. How it was showing in that new query tab. Okay. And already I show you that image section will come like this. Result also will. But this time why I am not getting, though it is executed, but it's the last time we try, otherwise we will move to other section. Okay. 5 0 2 0 2. At least error will be there, then we can assume like what, where is the error? But still it is not showing. Likewise, we have to do it. I will check for it, and next time I will tell you why I was not getting. I will see into that. Then we will move towards our next topic chapter. This is the next objects. But anyways, I did it on my workbench, and I got this step. Okay. After the call, we will execute likewise. Okay. And the output will come out in this way. Then another business case study for the stored procedure. Okay. So here, what it has been told, retail chain has the tables like products, order item, customers. So these are the elements, columns. Store manager wants a daily report list of products sold between two dates. Optional filter by category shows product name, category, total quantity, to total revenue. In stored procedure or automation, without stored procedure manually. If done manually, then every day we'll rewrite the query. Okay. So here no insert, update, delete. Okay. So you will not get error. Just simple manner. First the manual way. Okay. Select, because it wants only list of the products sold between two dates. Okay. And optional filter by category. And so product name, quantity, whatever it is written. So joins only, because already four tables are there. Okay. Primary key, foreign key. So through join will make it. And then where condition. So select whatever the column they want. You just mention and okay. So just go through. So product name, category, total quantity sold, and total revenue. Okay. 1, 2, 3, 4. Okay. So quantity sold, quantity into price. Okay. And sorry, revenue will be your sum of quantity into price, and total sold means your quantity, sum of quantity. Okay. So here product name, that alias, through the alias you will categorize. Okay. P dot product name, P dot category. Okay. And then sum of quantity, order items, and then alias total quantity sold, and then revenue like sum of sales, and sum of sales will be your price into quantity. Okay. As per your table name, you will just give the alias, then as total. Then from which table is the prime table, you will have to give the past. So just check for it. Products, product ID, product name, category, price. So it is the only primary key is there. Order, order ID, customer ID, order date, total amount. So two order ID, like one primary key, one foreign key without order item, order ID, product ID, quantity, unit price. So one, two, sorry. Okay, two foreign keys are there. Customer ID, primary key is there. So order items passed from order items, then join product name is there. No? So product first join will do with products. Okay. So from order items, okay, prime table, then join products on condition that product ID, okay, product ID, that P dot primary key, then OI dot foreign key, okay, that both common column, but for one table it is the primary key and for another table it has become foreign key. Then join orders because category in order table, okay, then join order, then order ID common it was there. Then where condition is order date, some date it was asked, okay, with procedure C category between the list of procedure products sold between two dates, okay. So any day, two dates that like Jan 1st to 31st Jan, okay. So where order date between these two dates will be differentiated by and. Then group by category based on the category. What will be the column? That product name and category. Okay. Non-aggregate column will be your group by. Okay. If it will be non-aggregated, then every non-aggregated column appear in the select must be used with group by. So product name category and the okay. Now we'll do in the store procedure way. So as per the syntax, we'll have to write create procedure, procedure name, okay, then parameter, then data type, okay, in start date, then in end date, okay, date, data type, then category, bharkar equals to not, optional filter, okay, then alias, begin and end, then in between that is select statement. What you write in manually, just put inside it, okay. Just remember this format. Okay. Then come to trigger. Trigger, what it does, it is used for auditing or changes. Okay. Trigger used for one table inside the table. Store procedure we did for multi-table. Here, trigger for one table. So a trigger is a special type of stored procedure in SQL that automatically executes in response to certain events that to on a table or view. Okay. Events include like insert, update, or delete. Triggers are used to enforce business rules, maintain audits, and synchronize the tables. Okay, trigger does the changes that causes another changes. Okay, so how the syntax, the delimiter, double dollar, okay, end will be the double dollar, then delimiter. Within that, create trigger, trigger name, then before, after, then DML commands insert, update, delete on table name for each row, on table name for each row. Okay, trigger will do each and every row it will impact. Then begin, then your SQL statements, then end. Begin to end inside it all the SQL statements. Okay, so remember in this way, it's completely similar to your store procedure. Only difference, store procedure is used for multi-table and trigger for only one table. Okay, let's see how in store procedure what we did here. Suppose one cell I inserted, that time it will automatically change the stock side. Let's see for trigger side how it will run. Suppose in our salary HR tracking system, we'll see. In salary update tracking, in our HR database, how we are doing. Sorry. A scenario is saying like an HR department wants to track the salary changes of employees. Okay. Whenever an employee's salary is updated in a new salary audit table, it will be seen like old salary with new salary must be recorded. Who got updated employee ID, then say third time of updated, like at what time it is getting updated, that change HR must know salary history for compliance. Create a trigger that automatically logs old and new salary values whenever salary is updated in the employee table. Okay. So employee table is there. What are the columns? Employee ID, employee name, salary, department. Okay. And in that salary audit, what you want? Audit ID, no doubt. Okay. Which new salary audit table. Okay. So that audit table will contain salary audit table will contain audit ID. Then your old salary with new salary. So, and then who got updated employee ID. So employee ID, old salary with new salary, then type. Okay. So 5 things they want. 1, 2, 3, 4, and then 5. Okay. So for that, our syntax will be delimiter to delimiter, delimiter dollar, and here double dollar, then delimiter, and in between create trigger name, then after update, because before or after. Okay. Here before create trigger, then before or after. Here we want after updated. Okay. Salary is updated. Getting this input. Okay, so after update on employees, here it is getting updated. So after update on employee for each row, here how I mentioned in that before or after, which one we are going to make after. In that DML commands, which one we want to do update. Okay, then on table name for each row. Okay, our table name will be which one? Employees table. Okay, where we are doing the update, that employee tables we are doing the updation. Okay, and that will be converted to salary table will be stored. So begin, then our select statement, then end. Okay, so let's see here how we are doing. So if old salary not equals to new salary, then we'll update. Okay, then that update will be come like insert into table name, new table name. Okay, salary audit. In that column name, employee ID, old salary, new salary, change that. Values will put old employee. In that employee ID, we'll keep old dot employee ID. In that old salary, definitely old dot salary. Okay. And then new salary, new dot salary, and that change that like now. Okay. That timestamp it will be shown. Then end if. Okay. Then your end. Okay. How it will come. So giving employee table like employee. So trigger what will do in same manner how stored procedure was doing. Once we insert, it will automatically change the stock side. Likewise, in trigger, what is the scenario? Like one employee table they have given, they are doing some changes, and in that changes they want to see in that audit table. Okay, taking all this input. So likewise, we'll do in the trigger because it's not for only one table. Okay, so we'll do use of the trigger. So we need to create trigger. Okay, first the table we need to create and insert the data, and again we'll create for the audit table, but in that audit table we need to insert the data automatically by trigger. So under this table, that audit table will apply trigger. Okay, that new table you want. Okay, so we'll have to create. Then we need to, once it is getting created, the trigger, we need to test it. Okay, by doing our updated statement. Then we need to check by select all queries. Okay. See here that trigger we used in HR department, like how it is happened. So old employee table, okay, as it is employee ID, employee name, salary, department, and data type and constraint. Okay, then insert data. Okay, in that core data set, again we need to create a salary new table, that is salary audit. Okay, in that how we want audit ID int auto increment primary key. Okay, then employee ID, old salary, new salary, change that. Okay, change that will be your date time function, that timestamp. Okay, then here we need to apply trigger. Rest. Okay, we need to execute something like okay, it is saying like we already existed. Okay, so here once we create it, let's see, it will be visible. Salary audit table. Okay, go here, trigger. Yes. Yeah, check. So one thing here, just salary audit table triggers. Okay, here it is nothing getting changed till now, but here in employee table, because the old table in employee table we apply trigger. We want to see here, check. Create trigger name after update on where on table name employees for each row. Okay, that's why it will visible in here. Okay, log salary, but how will we update once we test it? Okay, update employee where employee ID is equal to got executed. Now we will see by our select statement in salary audit. It has been changed. Only one we did it now. Okay. So one again for employee ID 2, again we will update and again we will check for select all. Then you can see for audit ID 2 and employee ID 2 it has been changed. Okay. And also that new salary, old salary and new salary it has changed and changed at which time. Now only we did it. Okay. That timestamp. Okay. Okay. Trigger. Now so nothing is there to tell. Okay, anyways, so trigger checks old that salary before update and new salary like salary after update. If they are not equal, okay, then only salary change history is inserted. Even if your auditable column is named old salary, trigger still takes the data from it as old dot salary and new dot salary will happen. Also, if then how like in Python or any other, how we are using like if else, okay. Likewise here, if condition that old salary not equal to new salary, then insert, then end it. Okay, that means if we don't use if, that means again it will insert the data every time. Okay, so that is the wrong. So how if else for Python, if else if here if end if. Okay, remember if then end if here if else. Then function, the last object is talking about function, reusable business logic. A function in MySQL is a stored program that takes input. What function will do? Function is the logic, like sum. Sum, what it does? A plus B. That means it will add A and B. Simple, it will take the input as A and B. Then logic is the plus, that means it adds and it will return a single value. Okay. But store procedure, it uses that reusable logic, but it will not return any single value. Okay. But whereas function, it returns the single value. That is the only difference. It will take input, it will perform the calculation, and it will return the single value. Okay. Remember, function is the very easiest way. Like it will take input, then do perform the calculation, and then gives the single out value as a output. Okay, it will return completely, it will return a single value as the output. Purpose, it reusable logic. Okay, calculate tax, discount, age, perform calculation like total price, bonus, discount, then data validation, check for correct format, return a single result, full name, salary status. Okay, use inside the select queries. Okay, select, calculate tax, like, okay, this is the only difference. Return single value. If we see like stored procedure, stored procedure is similar to your trigger. Okay. Only difference is the stored procedure is for multi-table, trigger is for one table. It is for automation. It is also for automation check. Okay. But in stored procedure, if we compare to function, then it uses reusable logic. It is also uses reusable logic. Only difference is sorry, function will return the value, single value as a output, but here it cannot return. Okay, just go through it. That's why it uses reusable logic, validate data, and perform the calculation and use inside the select queries. How the syntax will see. Delimiter, double dollar, n will be the delimiter. Inside that create function, function name. Inside that parameter name with data type. Then returns, return data type. Then deterministic. Okay. Then begin to end. And inside that your logic or select query statement and return value. Okay. Returns data type of a returned value. Okay, that remember, data type of the returned value. Okay, return values. Deterministic always returns the same output for the same input. Return mandatory. Function returns a single value. Used in select must have return and return data type. Okay, so case studies will see in a retail self store how it is happening. As we knew it, it is perform the calculation and returns the single value as a output. So in retail sector, how it is used, this function. A retail store wants to calculate the final price of a product after applying discount with GST tax percentage. Okay. So how we'll calculate it? Minus will be exclude the discount and include the tax in the price. Okay. So let's see, every cell needs that calculation repeatedly. Instead of writing long formulas every time, they want one function. For a table product, that column name, product ID, product name, price, discount percentage, tax percentage. Okay. Already the table creation, it has given create table name product, sorry, product ID int, then auto increment primary key constraint. Okay, product name, hacker, price, decimal, discount percent, decimal, tax percent, decimal. Okay, 3 to 5. 1, 2, 3, 4, 5. Okay. Create a MySQL function that takes price, discount percent, tax percentage that returns the final price. Okay. As I told, it uses the reusable logic. In the same manner, it will call the process like store procedure. Okay. So we'll give that time that price, discount, and tax. Okay. So that this will be our syntax based on the scenario, like As we know the syntax, delimiter, the double dollar, then end will be the delimiter. Okay. Then create function, function name, then component parameter with data type like price, discount percent, tax percent. We are taking price will be decimal data type, discount percent decimal data type, tax percent decimal data type. Okay. And then returns decimal. Okay. Returns with returns data type, then deterministic, then begin to end double dollar, begin to end double dollar. It will be like our query or logic, like declare discounted price data type. Okay. Declare again final price data type decimal. Okay. Discounted price final price. Okay. Step 1, apply discount. One more time we will do apply tax on discounted amount. Okay. On this discounted amount, set discount price equals to price minus price into discount percentage divided by 100. Okay. Final price, what will be happen, that discounted price plus discounted price into tax percentage, tax percentage by 100. Okay. Then return a final price. Okay. Again we need to create the table and insert the data, and then we need to create the function, and then we need to test it, and then we will get the output. In the same manner how we did in the store procedure that call the process, here also in the same manner we'll get. Okay. I have just elaborated these things. Here first create the table product. Okay. Then insert the data, then apply the function query, then calculate that final price function newly created. Select this and click on the right side second button as I told. Okay. Then a dialog box of the parameters like price, discount percentage, tax percentage you will get. Just enter the new values of the new product. Result will be executed accordingly on the same logic as shown in the image. Now final price will be valued. Okay. Then we'll take. Okay. Product table already it got created. Okay. Then insert data. Type table we have inserted. So whenever any new products items will be entered, we just gives the values accordingly. It will executed through the same logic. Okay. So here we need to apply. It got executed. Okay. Now we'll refresh and check in the function section where we'll get function under the database. Use store procedure function. Okay. So function has been created. That is function calculate final price. Okay. So here second button I will click. You see, I got price, discounted percentage, tax percentage. Okay. So suppose already I mentioned that for the price, suppose one product's price has been written like will give 70,000. 70,000. Discount percentage will give like 25. Tax percentage will give like 35. Okay. All the process. See, it got executed. 70,000, 25 people discount, and 35 will be tax percentage. Then our result will be like this one, 70,875. Okay. This time it got executed, but store procedure did not give the output. Anyways, I will see it. Okay. Hope you got it. Then move to our next. So these were the objects. I will show you. Objects, that 5 objects what we discussed so far: view, store procedure, function, index, trigger. So these top 3 for the under database and for multi-table. Though multi-tables, tables under database. These two is for only one table under table. Can use for many tables. So use for many tables. Okay. Store procedure. It is for general reusable logic. Function reusable logic returning values. Index created on specific columns. Trigger runs on insert, update, delete of that table. Okay. These three are database level and this below graph down to index and trigger for only table. So now it's time to your brainstorm. So this question, how much you got cleared into that? Let's see. So which SQL objects is a virtual table created from a select query? So tell me without going for the multiple choices. That is view. Then which SQL objects is used to perform automatic action when insert, update, delete happens? It is trigger. Okay, before or after update or insert or delete. Which SQL objects improves the speed? Index. How could you know? Tell me. Row, C, type, and then rows. Okay, type means all or range. If range means it is the indexed. Okay, and then C means that index name. Okay, and your rows means normal query, manual query. Rows will be full table scan and index scan. Rows will be less. Okay. The next slide. Which SQL objects must return a value in MySQL? Return a value function. Okay. Which SQL objects can accept parameters but cannot return a value? Can accept parameters but cannot. Which one? Stored procedure. Okay. Then which can a trigger not to do? Return trigger not to do. Access old and new values? Yes. Execute automatically? Yes. Hire before or after events? Only accept parameters. It does not do. Okay. Which SQL objects is based for reusable business logic? Calculate final price. It's a function. Okay. Because reusable business logic only used by one is function and one is the store procedure. But store procedure cannot return. Okay. Because also store procedure use general logic, reusable logic, not business reusable logic. Okay. Which SQL objects is stored under tables in MySQL workbench? Saw in audit table. Okay. Which SQL objects is stored under table? In sales audit table, we did it. That is trigger. Okay. Anyways, it is similar to your stored procedure, but stored procedure is happened under database. Here are under table. Okay. So trigger is the same as your stored procedure. Which SQL objects appear inside the database routine section in MySQL? Sorry, index trigger. It is table. Store procedure function. It is under database. View trigger no. Okay. Then a view is updated when automatically when underlying tables changes. Only when manually refreshed. No. Only when database restarts. No. Only after running analyze table. No. Automatically when underlying the tables. Okay. These parts are completely automation. Which SQL objects can modify table data directly? So this is trigger because after or before DML statement. Which SQL commands? So which SQL objects can contain insert, update, delete statements? Which SQL objects cannot contain? Among these, store procedure contain, trigger also contain, views also contain because many tables. Okay. So function. SQL objects physically stores data. Which SQL objects physically stores data? Views, no. Function, no. Stored procedure, no, because these are the automation index. Okay. What is the main purpose of the stored procedure? Improve the search performance, no. Automate business workflows, yes. Execute automatically, yes. Represent virtual table, no. Okay. So better answer will be automation. Okay. Business workflow. A before insert trigger can be used to return the value, no. Improve performance, no. Create views automatically, no. So last one is the stop inserting the incorrect data. Okay. Hope you got it. So this was the last slide. Just go through it. And remember the syntax. Let's go through it. So finally, we completed the SQL objects that talks about views, stored procedure, function, index, and trigger based on the tables, single table or multiple tables. Based on the business scenario, we saw the uses. So you understood and like the video. I can assure you by end of this, you got the much more clarity on this advanced SQL use cases. So now onwards, we will solve the advanced type of SQL queries based on this type of problem scenarios. I will see you soon with a new content with new series. Till then, bye bye. If you like the video, just like it and comment on the video and share it with your family and friends and subscribe. Don't forget the don't forget to subscribe the channel. Till then, bye bye. Take care. Have a good day. Jai Jagan.